Yes, sir.
In the previous session, we discussed, we started the sorting algorithms. Now, today we will complete the remaining algorithms. Yesterday, how many algorithms we have discussed? Sorting algorithms.
For you, sir.
For you, right? So first we discussed about the bubble sort, right? So working of the bubble sort we discussed by considering the simple example, and implementation part already you have completed at the time of practicals. You have shared the programs on a group also. And next, insertion sort. So working of the insertion sort and along with the example, so that part also we have completed. Next is the selection sort, and after that we discuss the merge sort and cell sort, right? Cell sort. Now today we will move to the next algorithm, or today we'll discuss the next algorithm, that is the quick sort. The screen is visible to all. Is it visible properly?
Yes, sir.
Yes, sir.
Okay, good. Now, this quick sort is in most of the application. So merge sort, quick sort. So these algorithms are used, right? And this quick sort is using the divide and conquer technique. So dividing the list into subparts, right? But one more concept here is introduced, that is the pivot, right? So how this pivot is considered, so that part we will discuss here, right? Now divide, in divide, so first pick the pivot element. After that, partition or rearrange the array into two sub-arrays such that the element is in the left sub-array is less than or equal to the pivot element, and element which are present in the right sub-array is larger than the pivot element. Now, how we are dividing the list? Now, normally in the previous divide and conquer approach, we are using in the previous algorithm in merge sort. So in that, what we are doing, we are dividing the list into equal parts and up to the last element, right? And after that, we are sorting and we are combining them. But here, so we are using the divide and conquer approach in a different ways. So we are considering one pivot element, and that pivot element we are comparing with the all the elements. Now, whatever the element is, we are comparing the value of that pivot element along with the remaining values which is present in the list, right? So if the element is less than that pivot element, we are shifting them to the left side of the pivot. And if the element is greater than the pivot, so we are keeping these greater element at the right side of the pivot, right? So we'll discuss this pivot element, how to use the pivot element by considering the examples. So after that, conquer. So recursively sort the two sub arrays with quick sort, and after that conquer and combine the, after that, once the sorting is completed, so combine the already sorted arrays. Now here, this block diagram is shown. Now here, one we are considering as a pivot, right? And one element we are considering as a pivot, and rest of the element we are keeping at left side and right side, and we are comparing each element with the pivot. Now this is the algorithm. So directly we'll go to the working of the quicksort so that you are able to understand. Now let's see the working of the quicksort algorithms, and after that we'll discuss the pseudocodes and everything. Now to understand the working of the quicksorts, so let's take an unsorted array. So this unsorted array we have considered 24, 9, 29, 14, 19, and 27. right? Now here in the given array, so we consider the leftmost element and rightmost element, right? So here, what is the leftmost element? Leftmost element का है?
24.
24.
And rightmost element is
27.
27.
27, right? Now here, so you can consider any element as a pivot. There is no any issues, right? You can consider left side element or you can consider right side. Here, I have considered the pivot is at left. So here I have considered the pivot is at left. So the algorithm is start from the right and move toward the left. If I consider the pivot element at left side or as a left element, so if I am considering the pivot element as a left, so I'm comparing the element from right to left, right? Now if I consider the right element as a pivot, so at that time what I will do, so I will compare the element which is present at the left side from left to the right, along with whom? Pivot element, right? So here, so I have considered the 24 as a pivot. Now, so all of you have given attention here. The condition is now a pivot. So what is the value of pivot here?
24.
Right, 24. And what is the value of right element?
27.
27.
27, right? Now here we are comparing these two elements. So pivot and right we are comparing and we are checking the pivot is less than right element. Pivot is less than the right element. Now what we are expecting, so those elements are greater than the pivot element. So these element we are keeping at which side, left side or right side? Pivot पेक्षा greater element कोणत्या साइडला ठेवतो आपण? Right side ला का left side ला?
Left side.
Greater element pivot पेक्षा greater असेल तर कोणत्या साइडला पाहिजे तो?
Right side.
Right side.
Right side.
And pivot पेक्षा लहान असेल तर? If the element
Left
is less
side.
than the pivot, then where we are keeping?
At the left.
At the left of the pivot, right? Now here the 27 we have compared with 24. Now 27 is greater than the pivot element.
Yes, sir.
Yes.
So is it necessary to change the position of 27? Is it
Yes,
at right
sir.
side? Right
Yes,
side ला
sir.
आहे का? Change करायची गरज आहे का ह्याची position?
No, sir.
No, sir.
Pivot च्या right side already the 27 is present at the right side of the pivot. Will not do any change here for the 27. Now move to the next 19. Now so algorithm moves forward one position towards the left, right? Now what is the next element here? Next element. Now right pointer is moved to the left side, so to the 19. Now compare. So now here left is 24, right is 19, and pivot is 24. Now compare. The pivot is greater than right. Now pivot is greater than right.
Yes,
Now,
sir.
is it allowed here? So pivot is
No, sir.
24 and 19 is less than the pivot. So we need to shift this 19 to which side? Left side.
Left
So
side.
here, so what we are doing? Shifting means what we are doing. So directly we are swapping the pivot element and this right element. So 19 we will swap with the 24 and 24 will keep here at the place of 19. So here, so algorithm will swap the pivot and right, and pivot moves to the right, right? आता इथं डायरेक्टली काय केलेलं आहे? पिवोटच पिवोट एलिमेंट काय केलेलं आहे? स्वॅप केलेलं आहे, right? So 19 and 24 is swap. Now 24 is at this location and now 19 is at this location. Now you can see here. Now what is the location of left now? Now what is the value of left now? आता left ची value काय असेल?
19.
19. And what is the value of pivot here?
24.
Pivot directly we have shifted here, right? And what is the value of right? Current value of right?
24.
Right. Now you can observe Now pivot is at left side or right side?
Right side.
Right side.
Right. Now, if the pivot is at right side, the algorithm is starting from left to right. जर pivot right side ला असेल तर आपण कुठल्या एलिमेंटशी आपण कंपेअर करतो त्याला लेफ्ट टू राइट कंपेअर करणार आहे. नाउ सो व्हॉट इज द व्हॅल्यू ऑफ लेफ्ट? What is the value of left here?
19.
19.
Now compare 19 with 24. Now who is greater here?
24.
24.
Is it correct?
Yes, sir.
Yes, sir.
19 is at correct place because the 19 value is less than the pivot value. Now move this left to the next pointer or next location. Now what is the value of left now? What is the value of left?
9.
9. And what is the value of pivot?
24.
24.
24. Now compare left and pivot. Compare kara left and pivot. So left is less than the pivot element. Yes or no?
Yes, sir.
Yes, sir.
So is it necessary to do the swapping?
No, sir.
No, sir.
No. 9 is less than the pivot element. So we'll keep 9 at the same location, right? Now move the left pointer to the next location. So now what is the value of left now?
29.
29.
Now compare 29 with the pivot element. Now left is greater than the pivot element. Yes or no?
Yes, sir.
Yes, sir.
Okay. Now what you need to do if the left side element is greater than the pivot element?
Shift it to right side.
We need to apply the swapping here. Now 24 is swapped at the place of 29 and 29 will shift at 24 location, right? Now here, now what is the location of pivot now? Pivot and left is at same location now, right? Now, if the pivot is at left location, then from where you need to compare the element? From right to left or left to right?
Right to left.
Right to left. Now, what is the value of right here?
29.
Now
29.
compare 29 with 24. 29 is greater, is it right? Right element is
sir.
greater than
Yes,
the
sir.
pivot. So right element always greater is required than the pivot element. Now move the right element to the left side. Now what is the value of right now?
14.
14.
14, right? Now, so is it allowed here 14?
No, sir.
Because the 14 is less than the pivot value. So what you need to do here?
Swapping.
Swapping. Now we'll apply the swapping here. 14 will be here and 24 will be here, right? So after swapping, so what is the value of pivot? Now pivot is at right or left now?
Right, sir.
Right.
Now pivot is at right side. Now from where you need to compare? From left to right or right to left?
Left to right.
Right.
Now what is
Left
the
to
value
right.
of left? What is the value of left?
14.
14.
Now compare 14 with 24. 14 is less than the pivot. So is it okay? Now left the move the left pointer to the next location. Now here the pivot, left and right, all these pointers are pointing to the same element. If the pivot, left and right, so if all these pointers are pointing to the same element, it means that here the first iteration will be or procedure will complete. This is the first iteration, right? Now here the statement I have written, right? So just I'm ready. So pivot 24, left 24, right 24. So pivot, left and right are pointing the same element. It represents the termination of procedure. Right now here the element 24, which is a pivot element, is placed is at exact position. Now you can observe here the position of 24. So 24 is placed at their exact position. So whatever the pivot element we have considered, so that element is placed at their exact position, right? Now, the elements are right side of the 24s are greater than it, and the elements that are left side of the 24s are smaller than it. So here, so these are the smaller element and these are the greater element. This is the left subarray and this is the right subarray. Now, what is the next step after first iteration? Now you can apply the same procedure now in the similar manner. Quicksort is separately applied to the left side of the subarray and right side of the subarray. Now here you can consider 19 as a pivot element and left element and 14 as a right element and compare it, do the comparison here. Follow the same procedure and sort out this left subarray. And here also, is it necessary? Here also we need to apply the quicksort, right, for these two elements. Now consider 29 as a pivot element and left element and 27 as a right element and apply the steps. So whatever the steps we have seen, right? Now the position of the 24 is now fixed, right? Now those elements are on the left side of the 24. So this element is called as a left subarray, and the element which are on the right side of the 24. So these element is called as a right subarray. Now same procedure, similar procedure is applied on the left subarray and right subarray. Now after that, so after applying the quicksort separately on the left side and right side subarray, so finally you will get the shorted list 9, 14, 19, 24, 27 and 20. Now here we have considered small list, so that's why so immediately you will get the, within 3 iterations you will get the shorted list. If the list is of 100 elements, so at that time it will take a time, right? Now all of you have understood how to consider the pivot element. This is called as a what? Quicksort. This is the working of the quicksort. Now picking a good pivot is necessary for the fast implementation of a quicksort. So it is difficult to determine the good pivot. Some of the ways of selecting the pivot. So first way, now there are 3 ways to select the pivot element. So first way is, so pivot can be random, any random. Select the random pivot from the given array, right? Or pivot can either be the rightmost element of the leftmost element of the given, rightmost or leftmost of the element. So either you can consider leftmost element or rightmost. Now we have followed the approach, this approach we have followed, right? Or select the median as a pivot element, or you can consider the middle element as a pivot element. So these are the 3 ways to select the pivot element. But comparisons and comparing, if the element is less than that pivot element, shifting to the left side or swapping, so this procedure is same. But when you are selecting the pivot, so for that purpose these 3 procedures are there, right? So you can select any number randomly. So this is one procedure or one way to select the pivot. And second way is the, either you can consider leftmost element or rightmost element. And third way, you can consider the middle element as a pivot element. That is depending on you. Now all of you have understood the quicksort. So here the first step is very important, that is selection of the pivot. And after that, next is the comparison. Once you have completed the first iteration, so you will get the 2 lists, left and right subarrays you will get. And again, you need to apply the quicksort on a left subarray and on a right subarray. All of you have understood the working of quick sort
Yes, sir.
and meaning of the pivot. How to select the pivot? Can anyone will give the answer of that question? So here
Randomly.
sorry.
Randomly select the pivot.
First way. Again, second way.
All the smaller elements should be in the left side and the larger elements should be at the right side.
Okay. This is the procedure. But what I am asking, so when you are selecting the pivot, so what kind of ways are there? So there are three ways. So random element, you can select randomly, you can select any of the element. Second way of selecting the pivot or deciding the pivot element is either you can consider the leftmost element or rightmost element. And third way is the
Middle, sir.
middle, right? Good. Now next, again, very interesting one. So is there any questions related with the quick sort? All of you understood? Sorry.
Yes, sir.
Now heap sort algorithm. So now next is the heap sort algorithm. Now here in the heap sort, so processes the element by creating the min heap and max heap. So using the elements of the given array. So min heap or max heap represent the ordering of array in which the root element represent the minimum or maximum element of the array, right? Now basically the two main operations we are performing on a heap or at the time of heap sorting. So first, build a heap using the elements of the array and repeatedly delete the root element of the heap formed in the first phase. Now first, how you are forming the heap, so that is also important. And when you are forming the heap, so at that time, whatever the root element you are considering, so that element should be greater element, right? जो हीपचा जो रूट एलिमेंट असेल तो कसा असणार आहे ग्रेटर असणार किंवा लेस असेल दॅट इज डिपेंडिंग ऑन यू सो इफ यू वॉन्ट टू यूज द इन्क्रिमेंटल अप्रोच or you want to use the decremental approach depending on that. And next one is the repeatedly for every iteration or for every phase, so we are removing the root element and we are storing in a sorted array, right? Now what is heap? So heap means what? So it is a complete binary tree, right? Have you heard the word binary tree? So what do you mean by binary tree? Binary tree कोणाला म्हणतो आपण? To whom we are calling binary tree? Anyone is aware with this binary tree concept? Hello. Yes or no? You know the concept of binary tree? Say yes, no, no. If you don't know, so we can say no.
A node which has two nodes.
Okay, good. Now, for example, so here I'll draw. Suppose this is the one root node, right? And here this root node is having two child. One is at left side and one is at the right side, right? And suppose you have child like this. Now, can we consider the second one as binary tree? त्याला binary tree म्हणू शकतो का second one?
No, sir.
No. Why?
Because it has more than two child nodes.
Now, can I consider this first tree as a binary tree?
Yes, sir.
Yes, because for every root, only two childs are there. For every root, only two childs are there. या प्रत्येक जो स्टार्टिंग नोड असतो, सुरुवातीचा नोड असतो, त्याला आपण काय म्हणतो, रूट नोड म्हणतो. रूट नोड is having the two childs only. So this kind of tree is called as a binary tree, right? Now here a heap is a complete binary tree, and binary tree is a tree in which the node can have at most two children, right? And a complete binary tree is a tree in which all the levels except the last level, that is leaf node, should be completely filled, and all the nodes should be left justified. Means what is the meaning of this statement? So if all nodes are there, now this part is a complete binary. This part, right? This is the complete binary, right? Now here right side is complete, but left side is incomplete, right? Now we'll see the examples here. Now what is the heap sort then? Now heap sort is a popular and efficient sorting algorithm. The concept of the heap sort is to eliminate the element one by one from the heap part of the list. So then insert them into the sorted part of the list. Now this is the in-place sorting algorithm. Now we'll see by considering the example how to use the Heapify process and everything. Now first step. So working. So when we this algorithm is working in two phases, right? Now all of you get it. So this list is visible to all. Is it visible?
Yes, sir.
Now whole block is visible to all. Now let's see the working of the heap sort in detail. So this is the unsorted array is given to you: 81, 99, 9, 11, 14, 76, 54, and 22. Now, first we have to construct a heap from the given array and convert it into the max heap, right? So first we will construct. So first element is the 81. Now all of you give attention how to construct the tree, heap tree. Now this is your unsorted array. All of you able to see the list of the unsorted array? Is it visible to all? Is this Sarvana?
Oh, sir.
Right. Now, what is the first step? So first step is the construct the heap. So here two steps we need to follow. The first step include the creation of heap by adjusting the elements of the array. And after creation of heap, now remove the root element of the heap repeatedly by shifting it to the end of the array, and then store the heap structure with the remaining element. Right. Now first step to create the array. Now create the tree. Now 81 will consider as a root. Now first we'll fill the left side and after that right side. Now 89 will shift at left side, 9 will shift at the right side. Now next element 11. So 11 will keep at the left of the 89, and 14 is at the right of the 89. After that 76 left of the 9 and 54 right of the 54, and 22 now next is the left of the 22. Now again one more, if any one more element is there, suppose 11, sorry, suppose 12 is there. So where 12 is inserted? Where it is added?
Under 11.
Under 11 at right side, right? And after that, is there any next element? So that will be added left of 14, right of 14. After that, left of 76, right of 76. Left of 54, right of 54. Or same, we are repeating left, right of all. So in this way, so first we have constructed the heap. Now, next procedure is apply the heapify. Now, after converting the given heap into the max heap, right? Now, how to convert them into the max heap? Max heap मध्ये कसं convert करणार? How to convert them into the max heap? So we are shifting the maximum valued element at the root side. Now we'll start from here. We'll start comparing the elements, root element and their child. Now 22 and 11 is there here. Now who is greater here? 22 or 11?
22.
If child element is greater than the root element, so we are shifting or we are swapping these two, right? So here the 11 is swapped with the 22. Now 22 is at this place. Now if the 22 is at this place, now compare 22 and 89. Sorry, 22 and 89. So who is greater here?
89.
89 will remain as it is. Now compare 14 and 89. Who is greater here?
89.
Right. Now here the 11, 22 and 14 will remain as it is. Now 89. Now come to this side. Now compare 89 with 81. Who is greater here?
89.
89. So what you need to do here?
Swap with root node.
Right. So 81 is shifted below and 89 will be shifted up. Right. Now we have started the heapifying process or max heap identification process from left side. Right. Now we'll go to the right side. Now come to right, left here, left one. Now 76 compare with the 9. Who is greater here?
76.
So 76 is shifted at root and 9 we are shifted at the child. Here you can observe. Now after that compare 76 with the 54. 76 with the 54. 54 will remain as it is, right? Now here the max heap process is completed. Now what we have done? So first thing is that we have constructed the heap by using the binary tree. So by considering this, and after that I have applied the heapify process. So in that heapify process, what I have done? So I have calculated the max heap. Now after converting the given heap into the max heap, the array elements are. Now you can tell me the array elements. Now what are the array elements? First element of the array after heapify. First element काय असेल बघितलं?
89.
89.
Second element.
81.
Third element.
22.
Level we need to follow. Level
76.
लेवल म्हणजे ती हा पहिला रूट, परत नंतर सेकंड, परत थर्ड लेवल आणि नंतर त्या खाली फोर्थ लेवल. फर्स्ट एलिमेंट 89, सेकंड 81, थर्ड
76.
फोर्थ
22.
नेक्स्ट
14.
आफ्टर दैट
9. 54. 11.
right. So after heapify, now we got this array. Now what this is the first step. So this is the first step of the heap sort algorithm. Now what is the next step? So after creation of heap, now remove the root element of the heap repeatedly by shifting it to the end of the array, and then store the heap structure with the remaining element. Now remove the first element. So root element काय आहे इथं? What is the root element? Root
89.
element 89.
89.
Next, we have to delete the root element 89 from the max heap. And to delete this root node, so we have to swap it with the last node. So what is the last node here?
11.
Now we need to swap this 89 with 11, and after that you can remove it, right? So after deleting the root element, so we again have to heapify to convert it into the max, right? Now again we are repeating the same process. Now after removing this 89, so that 89 is stored in a sorted list. 89 कुठं आला आता इथं लास्टला आलेला आहे आणि इथं लास्टचा एलिमेंट कोणता आहे 11. एलिमेंट कुठं शिफ्ट झाला फर्स्टला शिफ्ट झाला, राईट. सो दॅट इज शिफ्टेड ॲट फर्स्ट. जस्ट am I audible? Hello.
Yes, sir.
Yes, sir.
So what we are discussing? So we are discussing the first step. So what we have done, we have removed the 89 and remove means what we have done. So we have shifted 89 at the end of the this array and 11 we have shifted at the start, right? So after that, so prepare the or construct the heap by using the binary tree, right? So what is the first element now? 11. First element is now after deleting, after shifting this 89 at the end, so 11 we have shifted at the first location. So how to construct this 11 81? Is it visible to all?
Yes,
No.
sir.
11 first element, after that 81, after that 76, 22, 14, 9 and 54. Now heap after deleting the 89. So this heap is after deleting the 89. Now 89 we are not considering, right? Now we are not considering the 89. So 89 is considered as a maximum value of the list and already it is a sorted. Now apply the heapify process. Now how to apply the heapify process? Now we'll compare this 22 with 81. Now after that 14 to 81 and after that 81 to 11, right? 81 is shifted at this location and 11 will come here. Now after that again we need to compare 11 with the 22. So 11 will be shifted at the child side and 22 will be at the root side. Now here you can observe greater element we have shifted at the root. Now at this side also. So 9 is at, now here already they are in a sorted order, right? Now after swapping the array element, so 89 with the 11 and converting the heap into the max heap. Now write down the, now after that, so this after converting this heap into the max heap, so write down the array. So what is the first element now? What is the first element in the array? What is the
81,
next second element?
22,
Third,
6, 11, 14, 9,
9 and
54.
54. Now next delete 81. Delete means what you are doing. So with whom you need to replace here? आता इथं कोणावर रिप्लेस करणार तो सेकंड लास्ट एलिमेंट कोण आहे इथं
54.
now
54.
replace with the 54. Now again construct the heap after deleting 81. So draw the heap, right? Now apply the heapify process, max heap calculated. Again you can, after calculating the max heap, so convert it into the array, right? Or write down by using the array. Now remove the first element again. Now how to remove? So with whom you need to replace the 76 now?
9.
9. Okay. Now same procedure is repeated till end of the list. Same procedure. Now at the end, you will get only two elements. Last element 9, max 9, max 9. And here after removing the 9, so you will get the list empty. And here after completion of the sorting the array, so you will get this final list. Is it interesting? Heapify process, this heap sorting algorithm, working of the heap sort algorithm. Now all of you understood?
Yes.
Okay. Is it interesting?
Yes, sir.
Concept of the heap sort. Okay, good. Now we have completed the two concept. We have discussed the concept of quick sort and after that heap sort. And last one is the Radixsort, right? So last I will complete first and after that. Now Radixsort processes the element the same way in which the name of the students are sorted according to their alphabetical orders. So 26 radix in that case due to the 26 alphabets in our English. So 26 radix in the first pass we need to consider. Or names are grouped according to the ascending order of the first letter, right? So here the best example of the Radixsort is the dictionary, right? Alphabetically it is considered. Or you can sort these kind of numbers by considering their digits also, right? त्यांचे digits consider करून तुम्ही त्याचं sorting करू शकता. 0, 1, 2, 3, 4. Here we have in the first pass. So we are considering only the 0 digit. You can take the example for the Radixsort. So consider the array of length 6 given below and sort the array by using the Radixsort, right? Now here in the first sort, we are considering the 0th place only. Now 0th place is starting from where? From right to the left. So what is the value of 0th place here? याची 0th place value, sorry, 0th place value. So this is the array you want to sort, right? Consider an array of length 6 given below. Sort the array by using Radixsort. Now what is the 0th place of this array? This number.
10.
0th place, 0th right to left as 4 आहे. याचं किती आहे?
3,
याचं
1,
1.
याचं
2, 0.
2. Now sort by considering the zeroth place. Zeroth place consider करून sorting करा. So 0, 1, 2, 3, and 4. So in this way you will get the list. Right. Now consider the 2 digits, 10th digit, 10th place if you consider. So here 24. Here you will get 0, 3. Here 0, 1. After that 0 is already here, and 1, 0, and 0. So these first we'll consider only the 2-digit numbers, right? And after that we'll do the sorting of 3-digit numbers. So similar way we can consider the 100th place, right? 100 place consider केल्यानंतर काय होते? 803 आलं, इथं 901 आलं, right? 901 आलं, 803 आलं. Here 024, right? If you consider the 1000 place, so 1024 will be at the end, right? So therefore the list is generated in the step 4, right? Arranged from the Radixsort. So this kind of sorting is called as a Radixsort. Is there any difficulty in this? So here all sorting algorithm is complete. Now 3 algorithms today we have discussed. So first algorithm we have discussed, that is the which one? Quick sort. After that second one is the heap sort, and third one is the Radixsort. So all the 3 algorithms, all of you understood? Yes or no?
Yes, sir.
Yes, sir.
If you have understood, so you can write yes in the chat box. If you have not understood, so you can unmute yourself and ask the question. But here unit number 1 is completed.